So the last section in chapter 3, and I talked very little about this before, just to give us a preview. Some of you guys have taken the SAT, right? Or maybe ACT or some other standardized test. They normally report to you a percentile that you're in. And it's not exactly the same as a grade you make on a test. If you get an 80% on a test, what does that mean? You got 80% of the points, right? If you get an 80 percentile on an SAT, that does not mean you got 80% of the questions right or something. That means what?
You scored better than 80%.
I love it. You scored higher than 80% of everybody else who took that test. So it's a relative score. It's a little more fair, to tell you honestly, because they keep changing that test. So what if they randomly change it and make it everything a little bit harder than the other one? That's kind of mean. But then everybody's score should kind of go down a little bit. So relative, you'd still be the same score as you would have been. So it's very fair that way. It's more fair than it would be. Let's just say that. Making weird noises. So let me see if you guys can get your gut reaction is going to be wrong, but that's okay. We're going to figure out why your gut reaction is wrong. I'm going to make a list of 10 data points and put them in order.
We're doing 3.5, correct?
Where am I at here?
3.4.
3.6.
7, 8, 9. All right. 10. Yeah, this is section 3.4. That last section in chapter 3. So remember the very first thing in section 3.4 was the Z-score?
Yes.
So I told you that'd be on the test, but you didn't have to finish 3.4 homework yet. My online guys, don't worry. I'll figure out the percentage if you get that done later. Where do you think the 80th percentile would be?
Yeah.
And by the way, this would have the symbol P80. That's what 80th percentile would look like. Okay? Quick way to say this whole thing. So say again, I'm sorry?
34.
All right, so I have some votes for 31. And I have some votes for 34. I have a vote for 27. And why does 31, well, let's say, why does 34 make sense? What do we say about P80? It's got to have what percentage of the data below it?
80%.
And what's 80% of 10?
8.
So it makes sense. 1, 2, 3, 4, 5, 6, 7, 8. So this has got 8 things below it, doesn't it?
Mm-hmm.
But the 80th percentile should also have what percentage above it?
20.
20%.
So this one doesn't do that. This one's okay with the 80% below,
Somewhere in the middle.
but 20% above, no. This one is cool with 20% above, but the 80% below, no. Right? So exactly, who just said that? Somewhere in the middle, I love it. In fact, exactly in the middle. We already saw something like this. We've already done something like this, believe it or not. What other thing have we taken where we have to take between two numbers? Median. And what percentile would the median be? 50th, right? So it's the same idea. The median is really just a percentile. It's the easiest percentile, the thing right in the middle of everything. But it's somewhere we've already seen this happen. You're going to sometimes have to take in between. So what would P80 be?
32.5.
Yeah, 31 plus 34 divided by 2, 32.5. Oh, I feel some air. Thank God.
Now say it again. For the percentile, it has to be 80%. No. I mean,
So
rephrase
thank
it
God, I'm going to give you a very strict two-step process to find this. You don't have to kind of like tease it out like we just did. I just want to see what your gut reaction was. And your gut reaction was correct as far as the definition, but then we see how we have to adjust it a little bit. So how many numbers does 32.5 have below it? 8. And how many does it have above it?
2.
So it matches what I need, right? Now, when you get into like 79th percentile, a very small set of data doesn't really, it's going to be the same. If I only have 10 data points, I can't really differentiate that much between P79 and P80, right? They're going to be the same freaking number. So here's the two-step process, always, for finding a percentile. Step 1 is going to tell you where the the answer is. All right, so don't stop at step 1. That's where the answer is. Step 2, of course, is then go get the freaking answer. So step 1, if I want to find, let's see if you guys are, let's just do this specific one. If I want to find P80, the first step, how deep into my list do I want to go to get the 80th percentile? I want to go 80% of the way in. If I go 80% of the way in, I should find it, right? So I would take 80% of n, and in this case, that'd be 80% of 10. It's only 10 for this because there's 10 data points. So you took 80% of how big your list is. So you go in exactly that far. What is 80% of 10?
8.
8. Cool. So the 8th number is not the answer though, right? If it comes out to be a whole number, you take that one and the next one up and you average it. So it came out to be 8. So the answer is going to be the 8th and 9th average. If it comes out to be anything else, 8.1, 8.03, 8.9, you take the 9th number, you go up to the next whole number. So there's only 2 possible things here. And we've seen this already with median. So we'll do a median example next. So I got a whole number. That means I take the 8th and the 9th one and I average them. What's the 8th number? Here. And what's the 9th number there? So I do exactly like we did. I average those 2 together. The 8th and the 9th one, oops, I already have one. Be 31 plus 34 divided by 2, 32.5. Yes?
Okay, so if it was like 8.7 and you go to the 9th number,
Cool.
and would you take the average of the 9th?
No.
Or just the 9th?
You would take the 9th number.
Okay.
So you only take an average if you get a whole number answer, right? And actually that happens with the median too. If I have 4 things, how do I find P50, the median? 50% of 4 is
2 and 3 divided by
2. I get a 2, I got to take the second and the third. We know that. If there's 4 things, the answer's in the middle of the 2 in the middle, right? If there were 5 things,
take the 3.
the answer should be 3, right? This process better freaking give me 3. So what's half of 5? 2.5. That's not a whole number, so I round up to 3 and I take it. See, so the median is a specific example of a percentile.
Yeah, but so what would you round this number 32.5?
No, that's the answer. I mean, that's the number I round up would be where the answer is.
It's okay.
Then I go get the answer and I stop. That's the answer. I don't want to mess
Okay,
with that
so
at all.
this
That's
is-
the answer. Cool.
Okay.
I like it. Let's see. Here, you guys try this one here. Let's use this data. Let's see what's that. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13. Let's do 14. All right. So let me ask you a couple things here. I want you to find. Can you guys all see that over there? Okay. I want you to find P. What, Jeff? I don't know. P. Just come up with something. P50. So then find the median using the steps, and then I want you to find P25. So where are we at? Let's see. Oh, I like it.
I got the first
That's the first one. I love it. So do exactly what you just, well, not exactly what you just did, because the first problem to do the steps, what would the first step be for P50?
That would be
50% of
14.
14. So 0.5 times 14, half of 14 is
7.
7. Since that's a whole number, where's my answer?
In between 7 and
Average 7th and 8th. The 7th and 8th numbers are right there.
27.5.
I like it. So 27 plus 28 divided by 2, 27.5. That's P50. And of course, you could do that, the median, you can do it the old way. Even if you wanted, you could do the n plus 1 over 2. And what do you get when you do n plus 1 over 2? 14 plus 1 is 15, divided by 2 is 7 and a half, in between 7 and 8. Right? That's where that shortcut comes from. The shortcut comes from knowing the P50 is the median. They're the same thing. So it's really the steps we're talking about here. So that's an example where it came out to a whole number. So you got to average the two, that one and the next. 25% of 14 is
12 plus 17.
3.5.
3.5. So where's the answer?
15.5.
The fourth number is the answer, right? So 1, 2, 3, 4, 17.
Okay, I'm floored by this one.
Okay. So what is 25? You always do the percentile you want, that percentage of how long the list is, because that's how far I want to go in.
Okay,
So what is 25% of the way through 14 numbers?
it's 7. It's
0.25 times 14, right? 1/4 of the way through.
quarter through. Okay.
So 25% of 14, you multiply it out.
12 plus 7.
Okay. You get 3.5.
I ended up with 14 point something.
Oh. Neat.
Okay, so let me take this one.
Once you get where the answer is, you go get the answer. So a lot of people would stop here and say the answer is 4. Well, that doesn't make any sense. 4 is like right there. Right? The answer should be up here somewhere. 1/4 of the way through should be right about here. That makes sense. Okay, maybe. I'm always open.
So I get that we take the average when we end up with a whole number, and that we don't when we get a not a whole number.
Sweet.
What I don't understand is why.
It really has to do with, and with smaller lists, and I don't want to work with a list that's 1,000 numbers long, but with smaller lists, the percentiles don't work beautifully. Like, the difference between P23 and P24 is nothing if I only have 14 things. But the idea is exactly what we said earlier. P50 can't be either one of these, because this one has too few below it and this one has too few above it to be the number that's right in the middle of everybody. So it's got to be the number in the middle of those. So extend that idea, 80% like we did earlier. It's got to be the number that's 80% below it and 20% above it. So if you can't do it with either one of these, you average them to make that happen, right?
Yeah.
The reason I don't have to round, well, here I have to take the next one up. Here I got to go up. It's because I can't get 3.5 numbers below something. So the next best thing I can do is get 4 numbers, right? Or the fourth number in. I can't do 3.5 something, right? So the fourth number in I could do. Okay, maybe. Yeah.
How come you didn't add the 19 to 17
The 19, where are we at?
to 5?
Here?
And that's what
Because I
that's what
came
did.
out to 3.5. The rule is I round it up to the fourth number, right?
See,
If the answer is 4, that one, we have to bring it up 1, right? Like a number.
If I get a whole number, I average that one with the next one.
Okay.
If I don't get a whole number, if I get some decimal, I round it to the next integer, right? Because, again, 3.5 would be in between here, but 25% of the way in, I can't have 3.5. I go up here so that I can catch enough below it to have it close to be 25% of the whole thing. What is 3 out of 14? What is 3 divided by 14? Somebody help me out real quick. What is 3 divided by 14?
it's 0.214285714.
All right. Okay, cool.
It's
Right, and that's getting pretty close to 25%. That's the best I could do. So if I went to 3.5, it would be even a little worse. Don't you guys see? This guy has 21 something percent. I don't want to go any further down from that then, right? And in fact, what's if that's the fourth one, and there's 10 numbers up here. What's 10 divided by 14?
71.
Yeah, which is close to 75. If I don't do this one, I'm going to get far away from what I want to have happen. I want to have 25% below, about 75% above. When you have a small list of data, you can't get it to be perfect. You guys with me on that? Percentiles work really well with large sets of data because then you have a lot of data points that can fill in P23, P24, P25. When I have 14 data points, I can't get P33, P34. There's not enough data points to really fill all those up. Yes, ma'am?
So you get like, say like 11.2, round up to 12?
Beautiful. You always round up. Because you have to have at least 11.2, so how did you go up to 12?
Right.
Then you got at least 11.2. Yeah.
Okay, I'm not going back to that one, to just the first one. Now, when you did 0.5 multiplied by 14 equals 7. Now, what is that? I mean, I know that arrow. What does that say? 6?
That's his average.
Oh, yeah.
Yeah.
Oh, never mind. Duh.
That's right.
Okay.
Yeah.
Got you. Because I'm trying to write it like you did. So
Thankfully, I can read my own writing. I had a teacher once that if you didn't catch him right away, he'd have no idea. He'd look up in the notes. I have no idea what I wrote here. Does anybody know what I wrote here? He'd say to the class, and somebody say, "Oh yeah, you wrote that." Okay. But thankfully, I can. If you point it out, I can read my own writing. Okay. So here, you guys try this one real quick. Page 128. Number, yep. Number 26. You guys see how that refers to that list of data up there, starting at 36, 37, 37? Right, so that's the data 36, 37, 37, etc. Don't have your book, find a nice person near you, or a mean person that you can see their book. One of those two. So just like the median, they have to be in order for this to make sense. So be careful. You know me, I'm not going to give it to you in order on a test or a quiz. So the first thing you got to do is maybe put it in the calculator and sort it. All right, just like the median, it's got to be in order. Could be. Yeah, so step one would be, you want P95. So you want to go 95% of the way into your list. So So you take 95% of what?
24.
24. There's 24 Super Bowl total points up there, right? So 95% of 24. What's 0.95 times 24?
22.8.
So 23. Good. So you round up. It came out to not a whole number. So you round up to the next whole number, right? 23. You guys kind of see how you always go up somehow? If it's a whole number, you just take the next one up and average them. If it's anything else, you could take the next number, period. Right? There's only two kind of things to memorize here with these things. So what's the 23rd number? 69. And we don't really worry too much about repeats. You see how there's another 69 in there? There's nothing you can really do about that. You say that 69 is that percentile. Cool? So there are some old books that have a whole different way of looking at repeats. Thankfully, they came to consensus about that piece at least. So they said, screw the repeats, just give me the number you land on. So the answer will be 69. Cool. All right. So is that terrible? I mean, that's compared to some of the other stuff we've done so far. It's not too bad.
I'm not.
So what did you get for 95% of 24?
I didn't do it. I didn't finish it.
Oh, you got 23.
Yeah, but I didn't finish it.
Okay.
I got stuck right there.
Right there. What does that 23 mean? That's the first step is where the answer is. So go back to your list and go to the 23rd number. Now, of course, a shortcut, if you guys have a large P, like a P80, P95, just count down from the top. Say there's 24, so 24, 23. There you go. Instead of going 1, 2, 3, 4, 5, 6. Start the other side, go 24, 23, I'm done, yay, boom, right? And continue on. A little
So your best bet is actually to put it into the calculator.
Exactly. If it's not sorted, you want to put them in there.
Okay.
And the nice thing, if you put them in the calculator, they're numbered. The L1 is 1, L2, L3, yeah. So you can go exactly to the one you want. Okay, so kind of the next level of this, and that sucks, I kind of wanted to use that data, it's too bad for me. Another name for P25. And, you know, we see this all the time in football games, basketball games. If you're 25% of the way through a game, you say you're at the end of the first quarter. So thank God we called it, another name for this is Q1, for the first quarter. So what's Q2? I love it. So P50 is also known as Q2. And what's Q3?
75.
3 quarters makes 75 cents, so 75, I love it, right? If I calculate these three things, along with the low data point and the high data point, the incredibly creative name that people have come up with is the 5-number summary. This, altogether, is the 5-number summary. And you can make a visual of this. You can make a chart out of this thing. The chart's called a box and whisker chart. Not my words, the actual words of what it is. It's called a box and whisker plot. Or chart. I can't remember which one this book calls it, but oh well, too bad for us. The nice thing, you see this kind of thing all the time. Any of you future educators possibly? Yes, good, okay, a couple of you guys. You guys definitely need this, right? The rest of you need this because a lot of times they give in reviews of colleges, they give information from a box plot about like SAT scores of students who go to certain colleges and minimum incoming GPAs and stuff. They give it kind of like in a box plot format. So you got to know what the hell it means when you see one of these. So let's use that same set of data from that problem we just did. Take a minute and figure out the low,
36.
Q1, Q2, Q3, and the high. The low and the high obviously are nice.
From the data points on the board or
The data points from the problem we just did in the book.
oh, okay.
Cool? Yeah.
Yes. The low is not going to be this.
Yeah, so let's see. The low is 36, right? The high 75. Those are nice and easy.
Mm-hmm.
This is also sometimes known as the min and the max. just call them low and high. You guys might realize that once you get Q1, it's a really nice way to go get Q3. You don't have to do extra work for it. Kind of related to something I said earlier about starting at a certain spot in the list. What are you guys getting for
6 big.
yeah, 25% of 24, 1/4 of 24 is 6. That's a whole number, so you have to take the 6th and 7th ones, right? And average those together. What are the 6th and 7th? Say again?
41 and 43.
41 and 43? So 41 plus 43 divided by 2 is 42. Is that cool? Since it's 24, 4 goes into it. What else do I want to say here? So you can divide it 1/4, 1/2, and 3/4. They're all going to come out to be whole numbers. They're all going to be something you have to take averages to find, right? Half of 24 is 12. So you got to take the 12th and the 13th, right? It didn't come out to decimal, so I got to take that and the next one up. The 12th and 13th numbers are 53 and 54. So you get 53 and a half. And finally, 75% of 24, I'm sorry.
18.
All right, 75% of 24 is 18.
Yes.
So you're going to take the 18th and the 19th. But really up here, this is the 6th and 7th from the beginning. You could actually do the 6th and 7th from the end. You don't have to do like separate work down here. If you got to get that shortcut, if you don't get it, do it this way. It's not that big of a shortcut anyway. So what's the 18th and 19th numbers? 59 and 61?
Yes.
And of course, you get the average of those, and you get 60. So here's how you make this box and whisker plot. Definitely a strange name. It's very simple to make this thing, thank God. First off, you need a good scale. I got to be able to capture everything up there. I got to be able to capture the low all the way up through the high, right? So got to be able to go from 36 to 75. So maybe let's do 35 and then by 5s. So it's totally up to you what makes sense with your data. If you got to go from 10 to 1,000, you might not want to go by 5s, right? So it's up to you to figure out that scale. So 35, 40, 50, 60. How far did it do? 75? Okay, cool.
Doesn't it start at 36?
Exactly, it does. But I made 35 just so it's easier to count by 5s. The scale just has to catch all your data points. They all have to have a place within it. You don't have to start at 36. You start at something 36 or less. So there's a place for 36 in there, right? Now here's the funny thing. Every one of those 5 numbers, you just put a line right over it. So 36 is about right there. Bam. 42 is my Q1. Here's 42. Bam. 53 and a half.
And 60.
60.
And
then 75. I love it. All right, so far so good, right? That's pretty simple. And now, where's the box come from? The box comes from right in the middle. There's the box. Yeah, so this is Q1, Q2, Q3. So it boxes off all my middle quartiles there, right? And then whiskers are like this. Bam. So that's box and whiskers. They said, what the hell else can we call it?
I have a question.
Yeah.
It's 26 numbers in there.
Okay.
So what do you come up with?
26.
That's
No,
what I
there's
thought.
24, right?
Okay, so I'm the one screwing up. I'm sorry.
That's all right. No, they tell me, thank God, in the problem there's
Oh,
24,
okay,
yeah.
'cause I'm getting.
That's right. That's right. Yeah, definitely keep your eyes on me if I do a wrong
that's
thing.
why
The importance of this box, what can anybody tell me what percentage of the data is in that box? What percentage is from here to there?
5%.
50%.
Yeah. What percentage is below Q3? Below it, all the way down. What percentage is below Q3? That's 75%. What percentage is below Q1? 25%. So what percentage is between these two? 75 minus 25, right?
Okay.
So you see that all the time in these reviews of colleges. You see the middle 50% SAT scores or the middle 50% incoming GPAs or whatever. They love that middle box of like, here's where most of our students are. You know, or at least half of them. What is this to this? What's that?
100%.
100%, but what is it really related to something we've done before? That's the,
Population.
okay, cool, the range. I love it, right? So if you graphed another, let's say this is, what was this again? Did this have, oh yeah, this is Super Bowl stuff, right? So if you look at the Super Bowls before that, the 24 below, but before the last 24, and you get something like this, this is not what you necessarily get. Let's say you get that, just to have something to compare it to. What's one observation you can quickly make?
Same range.
Do they have the same range?
Small range.
This guy's range is from 45 to 65 roughly, right? So it's a lot tighter. Where's the median? Isn't it roughly the same place? Right, so the median didn't change by much, but for some reason, what changed?
The variation.
Good, and even better?
The top had more
Standard deviation, cool. The spread, the standard deviation of my data changed. So this is a very quick graph to make, and it has in it information about standard deviation, range, where the middle is, all that stuff is in it. So a very quick visual with a lot of good information in it. So they like to compare stuff. So in your homework, you have to make a box plot, but they also have like a box plot of men's heights and women's heights, and they say which one is which.
It's weights.
Or weights, yeah, I can remember. And that should be, pretty obvious if you know how to read a box plot, right? Women's heights or weights compared to men's weights, what should be true?
A lot lower.
Should be lower, plus there should be probably,
More variation.
well, for women there's actually normally less variation, maybe a little bit less, right? I can't remember from the book they gave you a specific example, yeah. But definitely a lower median for women. Okay, cool. So that's not too bad. I don't want to speak for you, but okay. So that's section 3.4. Is they start with z-scores. So there's going to be a few z-score problems, and then they get into percentiles, quartiles, box plots. So any questions over that before we get into chapter 4? I'm just going to do a little bit since I've got about 10 minutes left. You got to jump in there and try this out to see how it works.
Right there, what were you saying about the 25%? I mean, outside of Q1.
Yeah, Q1. What percentage is below Q1? Because Q1 is the
Okay,
first.
So it will be from 36 to.
No, what percentage? Q1 is also called P what? Q1 is the
25.
first quartile. So
Oh,
P25. So
25.
it's 25% below it.
Okay, okay.
And Q3 has 75% below. So how much is in there? 75 minus 25, 50%, always in that middle box. So no matter what box plot somebody shows you, you know that middle box is 50% of the data. You know it. You don't have to calculate anything. You just know it by looking at it. That's why it's very useful. Okay. There was a question in a much earlier homework that said, shoot, I can't remember what it said. Winning on one thing at a casino,
Oh, yes.
and then winning at the next one. You know, winning on one of those coins.
No.
You put a coin in and you win, yay! And then you move to the next one and you win again, yay! A lot of people said that's impossible.
But that was.
That's not right.
But that's not what the question said. The question said winning consecutively. It didn't say
Exactly.
change machines.
Oh, okay. Same machine even. Fine. Same machine. I can't remember. So you put something in, you win. You put something in again, you win again. Is that impossible?
No.
No.
No, but to win the jackpot consecutively over and over is nearly impossible.
No, they meant consecutively once and then again.
Okay, I thought it
Even
was
to
like
say-
one after the other.
Even to say you win it 80 times in a row in the same machine, is that impossible?
No.
No. So we get mixed up with really unlikely versus truly impossible. We get mixed up with that very easily. We're humans. It's only natural. We're like, wait, I never saw that happen. Of course, if some of you guys maybe have never stepped in a casino, you're not going to see a lot of things happen casino-wise. But if you've been to a casino, you maybe have never seen it happen. Does that mean it's impossible? Of course not. Right? Another little thing that's weird about our brains. If you were going to play like a 4-number lottery, like a 4-number lottery, would you pick the number 1, 2, 3, 4?
No.
You would pick. Give me an example. What would you pick?
25,
30, 39.
No, let's say it's single digits, right? One,
Seven.
0 through 9 for each one.
You got
7.
7, 3,
7, 3, 5,
or 8.
9. I love it, right? So our brain is telling. The funny thing is, you had all odd numbers, which our brain kind of likes as being somehow less likely or more random, right? But the question I asked you about pick a random number from 1 to 10. Most people pick the number 7. Because our brain says, oh, it's odd and it's up there, that's freaky. Let's say 7. 7, nobody else should say 7. We want to be unique, but everybody says 7 for the same reason. Right? So what's wrong with the reasoning not picking 1, 2, 3, 4 or 5, 5, 5, 5 and saying something else? Each individual number has exactly the same chance of winning, right? But what our brain does is it says, oh, it's not going to be a number like 1, 2, 3, 4. It's going to be some mixture of stuff. So let me just pick one of those. Those are more likely. What we're doing is we're grouping all of those together. What's the chances that it's not 1, 2, 3, 4? That's pretty damn high. The chances that it's not your number is really high, right? So our brain says 1, 2, 3, 4 is special. So it's less likely than like 7, 3, 5, 9. Somehow that's more likely in our brain. When you think about it, they're the same exact probability. 5, 5, 5, 5. Same probability, right? So I'm not one of the statisticians that never play the lottery. Every now and again I'll play. What the hell? You never know. Lightning strikes. You never know. But when I normally say it's kind of evil, I hate when I see people buying stuff when they should be buying bread or something. I'm like, come on, it's evil. Because what's going to happen is you're going to lose. Oh, put money on your losing, right? If you ever play craps, you have the guys always betting against you. Anybody ever play craps?
Yes.
You got those jackasses come over and bet against you? Okay, so there's some ground kind of normal mistakes to make with probability, right? What the hell is probability? How do I calculate probability? So, for example, if in the next classroom there were 30 men and 25 women, and I go in there with a blindfold and everybody kind of runs around and I reach out and I grab somebody, what's the probability that I just picked a man? And here's how I'd write that. Here's the probability. Here's the question in English. Probability of randomly selecting a man. Here's how it looks in Mathish. The probability of man. Right? So that's how you read this. The probability of doing this. In this case, picking a man. Can somebody come up with that? What that might be?
30 over 25.
Beautiful. Not 30 over 25. For one thing, that's higher than 100% chance. That's a little freaky, right? So it'd be 30 out of, because it's 30 men, so how many chances do you have to get a man? 30 chances out of the total people, 55. So probability at the heart of it, it's always going to be the total number of things that matches what you're looking for. Let me write this down because it sounds like a note. Probability is pretty much always built the same way. Probability of some event is the number of things matching that event divided by the total possibilities. So here I'm picking a person. So how many total people can I choose? 55. That's why the bottom was 55. Out of those 55, there are 30 chances for it to be a man. What is the problem? I see this a lot. This exact problem, I see somebody tell me this. Can you see that reasoning? Can you see why somebody would come up with that?
Yeah.
Some guys say no, which is actually kind of nice in a way, but I want you to go beyond what's right and see why that person would come up with this.
Because it
you're
says
only picking one of
one.
the 30 men.
So when you walk into that room, how many people could you pick? 55. So it's got to show up there somewhere. What this question would be, what's the probability of picking Sam, who's over there? Sam went over to that room, right? Out of the men, given that you picked a man. Then you got 30 people you could have picked, and one of them is Sam. That's way too specific. It's always got to be all the chances you have to do this, divided by all the number of things that could happen. So a very classic problem is cards. How many guys are really not playing cards? We're not going to start playing poker. Right? A lot of people think I'd be really good at poker because I'm all static. No, I'm not all that great at poker. Right? I don't have a poker face at all. And then I'm out. First one out. I'm gone. Bye, everybody. What? Anybody really not know cards, like how it's set up? You know, how many suits are in a deck of cards? Who doesn't know that? Anybody not know that? It's okay not to know it. Does everybody know? How many suits are there?
4.
What are they?
Diamond.
Yeah, hearts,
Club.
and clouds.
diamonds, clubs,
Yes.
spades. These two, of course, are the
The
red cards. These two are the...
black.
Black.
Right.
So I'm not only going to have card problems,
Yes,
but
34.
you can see how they're beautifully set up for probability questions. Right? How many cards are there in each suit?
13 each.
Exactly. There'll be, we'll count ace low for now. Ace, 2, 3, up to
King.
10, jack, queen,
King.
king. Cool. All the way down. So how many total cards are there?
52.
52. Right? If any of you have older brothers or sisters, maybe they force you to play 52 card pickup randomly, like my older sister did. She loved that. Jeff, it's good. No. So if I have a deck of cards, nicely shuffled, no jokers, no other shit, just the 52 basic cards, what's the probability that I would pick
1 over 52.
a 2?
Four.
What goes on the bottom? Start there.
Number of cards.
52.
52, right? Because it could be any of the cards. I don't know anything about the cards, so it could be any card. So it could be out of 52 cards, out of all the cards, how many match what I'm looking for?
4.
Oh,
How many?
got
Yeah.
4.
There's a 2 of hearts, a 2 of diamonds, a 2 of clubs, a 2 of spades. So don't look at that number. That's the kind of card it is, right?
Right.
In fact, in this case, that's not numerical data. That's the name of the card, really, in a way. So that'll be 4 out of 52, which reduces to... Now here's the cool thing, and this is the last thing I think I'll say. So hold up before you start packing up. Hold on. When you reduce a probability, that means very often it means there was another way to look at the problem. For every 13 cards on average, how many 2s are there?
1.
1 for every suit, right? So on average, there's 1 2 for every 13 cards. There's a whole other way I could have done the probability. So when you reduce a probability, very often that's what it means. There's another way to look at it. Okay. Cool. Oh,
So do you want us to leave it in fraction form?
yes,
or-
leave it fraction, yeah.
I'm
Or
okay
you can do
with
fraction and then make decimal, but I got to see the fraction so I can see the word.
Ask you a question.
Yeah.
Show me something.
Yeah.